Hi, and welcome to another statistics topic, this one focusing on experimental diagrams. How do you effectively diagram an experiment? How much detail? All those good things. So there's going to be looking a couple types for experimental diagrams. That's essentially what we are going to take a look at. So I figured we'll jump right on in and start looking at three types of designs. The first one is called a complete randomized design. Notice every experiment should use chance to divide the experimental units into their treatment group. So the way this kind of looks is something like this. You have your experimental units, could be people, rats, you never really know. Some kind of random assignment. I love the hat method. Write everybody's names on a hat, shake them on up, draw one out, split them up into treatment groups, and at the very end, compare whatever results you're interested in comparing. It's a very basic setup, kind of the run-of-the-mill, nothing too special. Let's get into one that's a little more specific. This one is called a blocked design. It's very similar to stratified sampling, but blocked is what this is called for experiment. So basically, you notice something similar among your groups. So maybe you want to divide males and females. Maybe you want to divide it by age. I want teenagers and adults. Maybe I want to divide them by weight. So maybe these people are all between 100 to 105 pounds, things like that. And then what you basically run is these mini experiments within each block, hopefully to reduce unwanted variation. So block experiments start out like this. Your experimental units. This is where you block them based on something they have in common. Maybe males in one group, females in another. You have a random assignment. That's what the RA will stand for. And then you have your treatments, 1, 2, 3, 1, 2, 3. They don't always have to be 3 treatments. Maybe there's just 2. Maybe there's 10. And then you compare that response variable. What are you interested in? Notice you do not compare at the very end. You keep them separate. That's the biggest misconception with blocking. The last one is very special and dear to my heart, pun intended, because it's a matched pair design. This one is kind of a special case, blocked randomization. This one can be used if you only have 2 treatments and you want the subjects to be either grouped in pairs or you want to use them twice. Maybe someone gets both treatments. And either way, you still use randomization. Experimental units. Notice you have all get treatment 1, all get treatment 2, and the random assignment comes in when you decide, okay, who gets what first. And then you compare the difference in the response variable. Okay, how much did their score improve? This is helpful with before and after experiments. Let's go and take a look at our first example. We have a research product for a Game Boy. You're trying to determine if changing product marketing will actually increase the sales. You want to verify whether the media, TV or radio, product presentation, should I put it in a box? Should I shrink wrap it? And hopefully how that will affect sales for a total of 24 different markets. So let's turn this on around and take a look at the first part. Again, experimental units, in this case, are the market regions. Notice it's not people. You have the market regions is where. Explanatory variable or factors, media, advertisement, and presentations. These are the ones that you're playing with. You're kind of adjusting. These are more like your variables. Response variable, what are you looking at in the very end? Hopefully you said sales. How many levels are there? This one's going to be a little tricky, but hopefully you have a 2 by 2 because the advertisements were TV or radio and presentation was box or shrinked, which launches us into how many treatments? You should have said 4. How many experimental units are required for each treatment? Well, if you have 4 treatments and 24 market regions, hopefully you got a little simple math and said 6. For each treatment group. Completely randomized experiment. So again, you start out with your experimental units, in this case, the 24 markets. From here, you have a random assignment. I said, put all markets on equal size piece of paper, put into a hat and shake it. Grab 6 markets without replacement, i.e. don't put those suckers back, and assign it to the first treatment. Repeat for the other 3. Notice, never put that back. You don't want that market having 4 different treatments. It could be a little confusing. So you're going to have 6 have the TV box combo, 6 have the radio box combo, 6 have the TV wrap combo, and 6 have the radio and wrap. So you have lots of different options. Again, bring them all back together. What am I looking at? Comparing some sales. Very simple, straight, full credit. Everything is there, clear as water, not clear as mud. This one's going to be a little different because let's say men and women respond differently to advertising. So Nintendo is assigning you to do that same experiment, but this time doing a randomized block design. You have 300 volunteers. Weren't they lucky? 180 men, 120 women. As your subjects, include how you plan to randomize the subjects. Always important. Controls, something to always consider. Well, hopefully you're showing everything on the same screen. Is the ad time the same? Are they shown at the same time? Are you doing the same product, the same year? All those kinds of things should be taken into consideration. Randomization, well, I'm going to block the 100 men, I'm going to block the 120 women, put all the men into a hat and mix it up, draw one name at a time to assign to the 3 treatments. I'm going to do that same process for the women. Replication. Replication doesn't mean doing the experiment always again. It just means using enough subject people. Well, I'm using 40 women per treatment and 60 men per treatment. I'm doing pretty good as far as replication is concerned. All right, again, start off with those 300 volunteers. Block those suckers out. You got the women, sample size of 120 men, have that sample size of 180. Scooch it on over. Notice there's the random assignment, which we've already discussed. From there, you have those 3 treatments, group 1, group 2, group 3. Add 1, add 2, add 3. Not too bad. And then again, compare. Be very specific. What am I probably comparing? Maybe how much they liked it, how much they responded to it, all that good stuff. Men are a little differently because there's only 60. Again, all 3 ads, and then compare. Notice you're done. Do not bring those 2 compares together. You cannot compare across blocks. Be very careful. Also, keep in mind, stratified sampling is only for observational studies and surveys. Blocking is for experiments. Be very careful on the vocabulary. They're very similar, but are used in different contexts. Vocabulary is super important. And honestly, here's a big idea. Block what you can and randomize what you can. If you're like, I really think this is too time consuming, okay, then randomize it. Don't block on it. All right, our last example is going to be a veterinary school would like to test a food supplement that is meant to increase joint flexibility in dogs. You have 12 dogs have been volunteered for this study by their owners. You're more than welcome to read the rest. We have a questionnaire, all of that good stuff. It says at the end, after 3 treatments, you'll be able to compare some results, 3 months of treatments. All right. So this one, we're going to try doing a matched pair because keep in mind, you have age and breed size that you need to kind of organize, so it's a little interesting. So what you want to try to do is put 2 small dogs together that are similar in age. Well, there's only 2 small dogs, so you kind of have to do that. Also, make sure you describe the blocks by number. Again, similar age, so not too bad. 2 and 5. Dog 2 is small. Dog 5 is small, similar in age. The mediums, you have a couple choices, but again, be very careful how you block them. Try to put, again, a medium size, similar in age. So notice dog 6 and dog 12 are both medium and a little younger. Dogs 8 and 11 are still a medium size, but they're the older ones. And then again, do the same thing for that. So notice you got all your blocks. You have 6 of them total. All right, part B. So again, randomization, put the names of 2 dogs in each block on slips of paper, mix the bag, draw one name out. That dog goes to the treatment group. The other one gets the control, and then repeat within each block. Part C. So since the owners are the ones evaluating the results, it's probably not important that they know if their dogs are getting the supplements. Again, the use of placebo allows the study to be blind. You don't want the owner answering the questions differently or changing other variables, like maybe giving their dog a little bit more exercise. Again, we don't want the results of the study to be affected based on the knowledge of which group their dog is in fact in. So be very careful, blind if you can. Not too bad. This has been Experimental Diagrams. Continue on for more fun statistics videos.